So today I'll be teaching you a bit about different types of variables um, and different data types. So we're going to touch base on integers and strings as well as floating points. And we're also going to touch on arrays. So we're not going to go into booleans yet until our next episode. Um, so the main thing I'm going to point out is that I've already created these and I will be addressing what they mean, but I will also give examples afterwards. So let's just get into it. And so the first thing I want to make comment on that is important are the signs that I use. So a star means multiplication. So multiplication, okay. This means the plus means addition. The negative means subtraction, and the slash means division. Now, when you have double time, like double star, that means power of. So it's given the power of. So it's basically the value times itself. So if we take a look at an input, okay, we can see that input equals 4. And we know that 4 is a number, so it's an integer. And in Python, we don't need to write int input, as it understands already what the data, what the variable is going to store. So if the variable is input, it doesn't understand what it's storing um, until we give it the data type, which is the number, so number 4. So if I were to make this 4.2, it would then understand that it's not an integer anymore, it's a double or a floating point. Okay, so we can see that underneath we've got another variable. Now this variable is called score, and what this line tells us is, sorry, that score will equal to input, which is 4, multiplied by 3. Okay, so that's what it's telling us. So here, if we put it 4 times 3, and in our last line here, print score. So this is telling us that at the end of it executing all this, nothing will happen unless you print out a score. So we're printing out score, and it's giving us a value that score is equal to. So the main reason we use different variables and data types within programs is we want to try and make this as helpful to our users as possible. We don't want to give them a program that has a fixed number. So if they want to convert feet to meters, for instance, we don't want them to just stay on 8 feet. So we don't want it to be fixed. We want them to be able to apply it to their type of program, like whatever they want to figure out, for instance. So if we run this, we can see that it equals 12. But if I were to change this to a 5 and run it, we see that we get 15. Now, if I were to remove this print sign, let's see what happens. So let me just change this to a 6. We can see nothing happened. It didn't print out anything. So if we remove that and run it, we then get the 18. Okay, so I'm going to create another one. Okay, and I'm going to call this let's call this add. Okay, so what's add going to equal? So add is going to equal to 5. Okay, I'm going to click enter. So the reason why these are different is because input is already found within the system. Add is not. Okay, and we're going to do so it's important to give appropriate names. So I'm going to change this to number. We'll just give it a number. And we're going to do another one, which is addition. Okay, and addition is equal to number plus 10. So whatever number equals, it's going to plus 10. Now I can run it now, and we can see that nothing really happened. So in Jupyter Notebook, you can create other things. So then I can say, in this one, I want to print out addition, and then it'll give me the value of what's in there. So that's a good thing. That's why I use Jupyter Notebook. It's far easier to work. So can print here, print addition, and we can see it equals to 15. So that's how it can work practically. Now I can also change the sign, and we'll see. We get -5. So um, so that's that. So we've got that working, and we can see that's fairly straightforward. So you give a value, you then move the value to here, then you do something with it before you print it out. Or you can just print out, so I can just print out number here, and it'll give me 5, but we don't want that, we want addition. Alright, now let's take a look here. So we can see that we've got input up here. So input is equal to 6, okay? But now we're using it in the same program. So we're not going into the kernel and we're not restarting or clearing our output. So that means that it's not removing the values already stored within different variables. So we're then updating it. So we're updating that input is equal to 5. But then we're going to print out score. So score is input times by 3. So if we run it, let's see what happens. Okay, so we got 18, but that's confusing because 6 times 3 is 18, as we found up here. So how does 5 equal to 18? So if 5 times 3 is 15, how's it 18? Alright, so the main problem we have here is we got the variable and we've got the value storing. So it's storing number 5. But we're not updating score. So scores remain the same because we haven't declared it back again. Okay? So here, I'll just make a note. We didn't declare score, which means score isn't updated, So this means that we're going to get whatever, so I can change this to 100 and we're still going to get 18. Alright, so we'll put that back to 5 and let's take a look. Okay, so if input equals 5, which we have up here, we don't really need that, then score equals input times 3. So let's run it and see what happens. This time we got 15. So I'm going to change this, alright? I'm going to change this to 7. Okay, let's just go up. I'm going to put that as 7. Okay, we're going to run that. Now I'm gonna remove this line and see what happens. Okay, let's see. Alright, so you've noticed that I didn't actually put an input up here, but I did like in this section. So we didn't have what input equals. So we don't know what it equals, but we did declare it up here, and that's how different programs work. Okay, so we're just gonna copy it and just put it here. Okay, now we can see that we got the updated version. So updating score to equal different number. EMT, different number. And we're then printing it. So I can always change this. We'll put 100 and we'll see 300. See? So we're just going to put that back as 5. Okay. May as well put that 5 there. Okay. So this is showing how it's important to update everything when you're trying to create a new program, and how different variables can store different numbers or different values and data types. But if you want it to update, you've got to update the whole thing. You can't just update, say for instance, input and then print score, which you haven't updated since the first execution line at the top. Because as we know that when it comes to programming, code is read line by line and it's read downwards. So it reads A and then B and then C. But obviously if you have more writing near it, it's going to execute all of them before it goes to B and then goes to C. So you gotta make sure that you understand that concept, that if it's going to read line A, which is updating score, so score was updated here, but then we go to C, and score was only printed. So we'll say P and it's S, so that means print score. We're only printing what has been already executed in line 1. So line 1 is that one, which is, this is line 3. So there's nothing happening except we're just bringing that back there. Okay, so now that we've understood that, just close that off. Okay, so here is another method. So I've given an example of addition up here. Now I'm going to show how you could use it in many. So a main way you can use this is a equals to 10. So we've already declared that it's an integer, and b is equal to a take away 10. So we know that we're doing subtraction. Okay, and we're going to print out b. So what's a? So if a equals to 10, so a equals to 10, and b equals to 10 take away 10, which equals to 0. Alright, so I'm just using double equals to make it more understandable. And if I were to run it, we get 0 like we see here. Now what if I made this 11? Let's take a look. We get 1. Okay, so it's understandable that when you update a value within the same program, it updates the whole thing. So we've done this one already. So this is pretty much the same thing up here. It's just another example. So a is 20. So then we call a down here. So we got this is basically 20 here, and we're taking away 15. Now we can understand that within this program that we've already done all this before, and we're going to get 5. So if I change this to 25, we should get 10. All right, it's fairly straightforward, but we'll leave that as 20 for now. All right, so now this is when we get into integers and floating points or decimals. Um, this is different. So this is how we can now do conversions. Okay, so we can see that pets is equal to 2, which is a solid number, which is an integer. Okay, so we can see, as I said, pets is an integer, and we're going to print out the solid number of 2. And we did right here. But temperature, we know that temperature can be different. We're not going to always get a 40-degree day. We might get a 37.5-degree day. And so we can see that that's a floating point or a decimal, whatever you want to call it. And when we print it, we're going to get 37.5. So we can understand that those are two different values. So if I get out paint again, I'm going to say, so decimal is equal to floating, whereas int is is a solid. It's a solid number. So or just imagine that the other way around. Sorry. Yeah. So an example I'll give is 30. Okay, and I'll give 31.1. So let's see. The difference is the decimal is this one here. It's a floating point. Whereas the solid, which is to the nearest 1, nearest 100, nearest whatever, that doesn't have a point and a number after it, is going to be the integer. Okay, so that's the main difference that we want to understand. Okay, so let's go back here. Now we're going to understand how it's applicable within real life. So if we do tax, okay, so you can just Google search whatever country you're in. Okay, so what amount of tax is given? It's given. No. What is the amount of tax in Australia? Maybe it'll give us. Okay, so this is on GST. I'll say GST. Okay, I spelled it wrong. What is it? So 10%, we understand that 10% is the GST that we pay on goods. Okay, so if I were to change this to 10%, which is 10 over 100, that value will change. So we can understand that the price already is 8. So we'll say that's $8, alright, but we can't put the sign in. So that's $8. So $8 times it by 10 divided by 100. Now, understanding BOD math, alright? So brackets of division, multiplication, subtraction, and whatnot. Okay? So you begin with the brackets and you deal what's inside there first. So we've already got that done. So we do that and we should get, I should put that in. We should get that. Okay? So the way we do it is just move, pretend there's a decimal there. We're going to move it twice. Once, twice. Okay? So we've got 10 and then we've got 100. Okay? 100 has 2 zeros. 10 has 1. But there's no decimal. Okay? So the decimal's there. We're going to move it once for 1 0. So we get rid of that 0. And then one more time for another 0. So we get 0 0.10. So that's what we get. So let's see, what else do we need? So we've understood that it's 0.10, and we're timesing that by 8. So 8. Okay, so 8.00 times it by 0.10, and we're going to get our tax. So our tax is 80 cents. Okay, so we're spending 80 cents on tax when we're getting the product of what sort. So it's understandable. So I'm going to give another example. Okay, so we're going to say egg. So an egg costs $3. Okay, $3 for a batch of 12. Okay, now we're going to print out the tax. So tax equals to egg. We're going to multiply it by, so we can do it again like 10 like that, or we can just put in the decimal point like that. And we're just going to print out, we're going to actually change that to GST so we don't muck up that one up there. And we're going to print out GST. Okay, and we can see that GST is equal to that. So the reason why it's like that is because 3 is a bad number to use. I'm going to change that to 4. There we are. Now I don't really understand why I gave it off like that, to be honest. Okay, that was a little weird. Okay, so we're paying 40 cents for the egg. So I hope that's understandable on how it's applicable in the real world. All right, moving on. So strings are just characters of letters, so A, B, C, just put together to make something meaningful. So in this, we've got the the variable we're using is called forename. So we can change it to whatever we want, and it's going to hold the value of Joe. So when I call it, it should say Joe. Now I'm going to remove this line for now, and I'm just going to print this and see what happens. So when I print out forename, it gives me my name. Okay, it brings back Joe. Okay, so something that people like to see as well is when you use len. So len stands for length. So I can say len and then forename, for instance. So len forename. Okay. Now when I run this, it tells me how many letters. So if I put more and I run it, we can see that it prints out the new updated forename of Joe. And it tells me that there's 10 characters in it. So if I put in my full name, alright, I'm not going to put the rest in, just leave it like that, and run it, we can see that it tells us 12, okay? Or 9 without the dots. So I'm just going to leave it as Joe. Okay. So it's understandable of what len does. It just tells you how many characters are in it. So 1, 2, 3. There's 3 characters within it. Now if we move on, sorry if I'm going too fast. If I'm going too fast, let me know in the comments to slow down or to create the the page while I'm working with you guys instead. So instead of have it already created, I can just program it with you. So this one is a happy birthday type, okay? And this teaches us how to combine different types of variables in the one program. Okay, so the first thing we understand is happy holds all this, and name holds name. Now we can see that at the end, we've left a spacebar, and same with Joey. We've left a spacebar. Now, the reason why we do this is if we don't have a spacebar, the next, so if I call happy after it, then happy, so this part, will be right on the Y. So it'll be like this. It'll be like that. Instead, if we had the spacebar, it'll be like that. Okay. Now we can see that in song, we're calling happy. So happy birthday to you is called there. And we're calling it again. So the plus allows us to combine more. Okay. So happy, we're calling it again. Happy birthday to you. We're adding a plus. And now we added our own string in there. Okay. Happy birthday, dear. As we didn't use this in one of these, so we don't have a variable holding that. If we did, we could just name it. So I'll just do it for, I'll just write who, and then I'll just copy that in like so. Type in who, paste that there, and then name. So who, happy birthday, dear, and then name, Joey. Okay. Now let's print it and see what happens. We can see that it gives the exact same thing. But if I were to just remove who, like so, paste that there, click enter, we get the same thing. Okay. And you've probably noticed that I didn't write print song. Okay. Now watch what happens when I write print and then song. What happened? Did you notice anything? I'll go back one. Okay. Alright. So you probably noticed it now. There are one quotation marks within it. So we have at the start and at the end. There's little one quotation. Okay. So that's what happens when you just write song. So if I write print song, it removes and just becomes one full line of text without quotations. But we're going to leave it like that. Okay, so we've understood different types of data types. Now we're going to learn how to combine them together. As we know that if we use a number, so if I use me, and I'm going to make it to 17, okay? And I want to print it within the text. So your age is spacebar quote plus, and I call age. Let's look at, and I call me. Let's see what the error comes. Okay, let's see. So we found that there's a problem, as we can see with the arrow, is in the print. Your name, your age is, and then plus me. So this tells us that you cannot use a string and an integer in the same line. Okay, so that's the error that we've got here. So if we look here, we can see that age is an integer. Let's run it and see. We didn't get the error. So the main reason we didn't get the error is because we use str. So although we don't need to use, for instance, int to declare that age is an integer, or str to use it for a string, we use them to change and convert them into a method or into a way that we can display it within the same type of line. So if we're printing it, as we saw here, we can't. But if I did str brackets me like so and run it, then it works. Your age is 17. Okay, so I hope that's understandable. I'll just go over it one more time. You need this when you're adding an integer in the same line as a string. That's what it is. Okay. Now we can see that len string age. So this shows you how in multiple ways you can do it. Alright, so if I were to do len and then just age and run it, we can see that int has no length. It's a number. You can't get a length of a number. But by putting, as we see above, string, we're making it characters. So that's one character and that's two characters. So we got two characters here, the number 1 and the number 9. Okay, and that's why we can print out 2. Obviously, if we added another number in it, it becomes 3. So we're just going to leave it as 19 for now and leave it as 2. Alright, so this is when the fun begins. So now we're using arrays. So arrays are when we have more than one data. It can be both data types or just data in general in one variable. Okay. Okay, so this means, as we can see here, that in my list we have number 1, but then we wanted to store more than a 1. We wanted to store the words 2, and then 3, 4, 5, and then 7.5. Okay, so let's see. How does this work? So when we use a regular one, so if I were to say a equals to 19, we don't have anything in it, okay? We don't have a brackets around it, square brackets. But when you use the arrays, you need to use these square brackets, alright, the boxy ones. They can be found next to the letters P and the backslash if you're on a Windows computer. Now, by putting them in a list or in an array, we can see how, let's count how many values. Okay, so we've got 1, 2, 3, 4, 5, 6. Okay, we've got 6. So we've got an array, and I'm just going to write 1, 2, 3, 4, 5, 6. So we're going to pretend that's called A. We have 6 numbers in the array, but there's actually 5 different data types. Not really data types. There's 5 different there's 5, just 5 points. All right, 1, 2, 3, 4, 5, and 6. So we can see there's 6, but I'm saying there's 5. So the way you figure this out is A take away 1. So this is the array, and you take away 1. As it doesn't begin with so the first data type doesn't begin as number 1. It starts at 0. The second one, 1. Third, 2. Fourth, 3. Fifth, 4. 6, 5. So that's how you do it. So if I wanted to call out number 1, I'll do A square brackets 0. Okay, so that's for me to print that. I wouldn't say, I wouldn't put in the number 1. Okay, because then they'll give me 2 instead. So I hope that's understandable. I'll go into more details later on in this video. Okay, so let's just run that, and we see nothing happens because we're not doing anything with it. So we're just going to print my list. So when we print my list, it gives it all. And we've noticed that because we have a string in there, it's given it in single quotation marks to tell you that that's a string and not an integer. Okay, so as I was saying before, the size of an array is the size take away 1. So it's my list, take away 1, which equals to, as we've declared, 5. 1, 2, 3, 4, 5, 6. 6 take 1 is 5. Okay, and by using number 2, we're declaring 1, 0, 1, 2. We're declaring the number 3 to come in. If I put in number 0, you can see that there's no 0 in here. There's just 1 to 6. When I run it, I get number 1 because that's the first value, the 0 value. But we're just going to put that back to number 3. Let's see that we get number 4. Now, let's see what happens if I write number 6. So there's an error, all right? List index out of range. Okay, if I had another value, it'll give me that value. But it's out of range because we've only got between 0 and 5 here. not 1 and 6. So if I were to change that to 5, I get 7.5. Alright, so that's a wrap. So um, in this video, we looked at different types of variables and data types involving integers, arrays, strings, and floating points. So in our next video, I'm going to go through if statements, booleans, and if I have time, I might go into files and address it. Um, and I'll just address in the first few minutes of the video on what I'll actually be touching base on. So I hope you enjoyed. Please like and subscribe. If you have any questions, please put it in the comment section. Thank you and have a good day.